with companies and inventors to find ways for them to work in offshore wind energy. I use maths every day, and I'm going to show you just some ways I use maths to help people learn about offshore wind and how they can make inventions to help us make energy cheaper, safer, more reliable. So I'll take you from the birth to the death of an offshore wind farm. Before you even start thinking about building an offshore wind farm, you need to know that there's enough wind to power the turbines. Now, wind comes in, turns the blades, and that, through turning magnets within coils of wire, generates electricity that gets sent down the cable back to land and uses that to power our homes, our TVs, our internet. Now, there are different equations and mathematical ways to work out how much electricity is going to be made from one turbine or a whole farm, depending on how fast the wind is blowing. We also use different types of models to predict how often the wind is blowing that speed, whether that happens during the summer or the winter, or whether it happens more offshore or nearer to shore. We use all that math and all that figures to work out whether it's worth actually building a turbine on the water in these locations or not. I even work with satellite companies that are building new CubeSats about this size to send them up into space so that we can have more information about how fast the wind is blowing offshore in remote locations. And they use this using different types of beams that hit off the clouds and using maths again to work out the wind speeds in the first place. In every single one of these steps, maths is used every single time. So once you've worked out the best place for your turbine, the next thing to work out is what kind of turbine to put out into the water. Now, there's loads of different types of turbines, sizes, and they all have different types of forces on them. Some of them are much heavier, some of them are lighter, and we need maths to work out how much force is pushing the wind turbines over, how much strength we might need, what kind of foundations we need, what kind of generator to have. Every single one of these designs uses maths to work out the lightest and the cheapest turbine that we can use offshore. Then we need to actually build the turbines offshore. Now, there's loads of maths to do with that. Firstly, we need to work out how expensive is it going to be to get people out onto boats and building the turbines offshore. We use robots sometimes to do a lot of the lifting or detecting underwater, and robots are just maths. They use all sorts of different algorithms to decide what to do, and those algorithms in a computer are done by people, and all algorithms are just maths. Then once a wind farm's built and ready, there is so much maths that goes into operating a wind farm. For example, a wind turbine might be out in the water for 25 years, which is a really long time. There's a lot of sea salt and spray and wind and rain that slowly degrades the turbine, and we need to use maths to predict when the turbine might break, to predict what bits might break, and when the best time is to fix it. It's a bit like servicing your car. It's better to fix things before they become a problem and break other stuff as well. So a lot of maths goes into predicting how to fix a turbine. There's also a lot of maths that goes into predicting how much electricity is coming out every minute and selling that electricity to the grid. One of the most stressful jobs in the world is an energy trader. What they use is a lot of the weather forecasts, the turbine models, all sorts of numbers, and predict how much electricity is going to be made every single half hour in the day. And every single half hour they need to tell the grid, we're going to be making 5 megawatts of energy, or whatever it's going to be. And if they're wrong, the turbine company gets charged a lot of money for being wrong, because the grid need to know where their energy is coming from and how much is going to be used by everyone in their homes and offices and businesses. So if the energy trader is wrong, it costs a lot of money, and that's really stressful, but everything about that is maths and numbers and modelling predictions. Then even at the end of a turbine's life, there's a lot of maths that goes into what's the best way to remove the turbine and the safest way to make sure that animals are protected, that the sea is protected, and that we can make sure that the turbine is being used in the most efficient way possible. So we use a lot of numbers, like the cost of decommissioning, it's called the cost of removing the turbine. We look at numbers of sea creatures like seals and different types of sea life to see what might be growing underneath the turbine. So I need to know and understand the maths to make sure that people are marketing the right things and building the right inventions and helping people out. So maths is great. One of my favourite things is making a nice graph or making a nice picture and working out the numbers in a visual way to help me know what it means and understand it. So I hope you have a great maths week, and thanks for listening. Bye!